Okay, so I want to talk to you today about the UTK Filament Tower. This was part of an exhibition I designed and fabricated with the help of many students, collaborators, and industrial sponsors here at the University of Tennessee. And so the project really builds from an integrated computational design process. And this incorporates strategies to understand material behavior, structural performance, and digital fabrication logics into a generative computational design tool. And so this often builds from a biomimetic investigation. So biological structures are naturally material efficient. They're often structurally performative, but more importantly, they successfully integrate multiple internal and external conditions into their growth and developmental processes. And these systems are typically fibrous in nature. And so, like our technical composites, glass and carbon fiber, these principles can be used to integrate more performative engineering scenarios, like applications that are often dependent on surface molds or serialized production. These aren't typically adaptable for architectural applications. So over the past few years, I've researched several ways to use composites at an architectural scale, integrating various biological principles, exploring a range of structural scenarios, and investigating many design possibilities. So in Columbus, Indiana, the site of the exhibition, this is a small town with many architectural treasures. It's kind of an architectural mecca. And so many of these buildings are very iconic towers, which is a structural scenario that I hadn't tested before in these composite structures. And so I explored this from a design standpoint, using these computational design processes to generate this tower form, simulating the material behavior, form finding the structural components, and analyzing the loads and force distributions to calculate if we needed to reinforce it further with carbon fibers. So this resulted in a 30-foot tower made of unique and differentiated fiber wound components. And this is a very efficient additive manufacturing process with very little waste. Each component had a fiberglass body and a carbon fiber reinforcement only where it needed. The tower was an open lattice tube that visitors could look up through the center and see it open at the top. A few base components were designed to be 3D printed as benches and foundations for the tower. These benches were 3D printed with help from Oak Ridge National Laboratory in their manufacturing demonstration facility. They have what they call the BAM machine, which is one of the world's largest 3D printers of its kind. The fiber composite components were manufactured in the UTK Fablab, just downtown on Gay Street. We have a large industrial robot with a 3-meter reach on an 8-meter track with 2 additional axes. And so this enables a wide variety of things that we can make, from 5-axis milling to large format 3D printing and now robotic fiber winding. So the robotic setup was similar to that of a rotisserie, which enabled us to produce components up to 10 feet long on a rotating axis with this reconfigurable frame. And so the reconfigurable frame was made from a kit of parts that enabled a wide variety of geometries to be made. The frame also eliminated the need for surface molds. So no additional material was needed to generate these differentiated forms, and so material didn't have to be wasted for this process. When we look at the fiber winding process, you'll see that we built up the fiberglass body incrementally strand by strand. Laying resin-impregnated fibers formed a strong structural composite. And then the density and the fiber directionality could be very specifically controlled per the structural requirements of each component. When we look at that at a much faster speed, you see that this process is very repetitive and simplistic, but actually enabled a wide variety of geometries to be manufactured autonomously and adaptively. So in total, we made 27 fiber composite components, each unique and differentiated. And we had 3 3D printed bases that we made. And so these were packed up into a 15-foot box truck and shipped up to Columbus last August. And with the help of our wonderful students in the architectural program and some engineering students, we set it up in August, and the exhibition ran through last December. And so this was an interesting opportunity where the tower was situated just outside of North Christian Church by architect Eero Saarinen. And there was a great dialogue between the tower and the church spire. At night, the components were lit internally and would glow. The glass fiber functioned a little bit like an optic fiber and would transmit light throughout the structure. This silhouetted the carbon fiber form and created an incredible filigree pattern across the structure. So there was an airiness to the structure that you don't get from standard concrete or steel structures, and this changed the way we thought about structures, really. We hope that the tower might be a beacon for the exhibition and really draw people in to showcase novel architectural research. It's also a good time to mention that I'm always looking for future collaborators. Thank you.